Hey everybody, in this video we are going to condense some logarithmic expressions. We are in section 3, properties of logarithms, example 5 in the unit on exponential and logarithmic functions. If you need more detail about the 3 properties that I am using, you can look at examples 1, 2, and 3. And if you want to see how we expand from a condensed logarithm, you could look at example 4, which is the one right before this one. All right, so let's get into this. So the first example here, when you read the directions on like a test or a quiz on this particular topic, you're going to look for certain key phrases like condense the following or put it into a single logarithm, yada, yada, yada. Now, are there other ways to do this? Can we evaluate, in this particular case, that expression, and add it? We could, right? You could look at it as 4 to what power is 2? The answer is 1/2, although people accidentally put 2. 4 to what power is 32? I don't know what people are going to get all the time, but the answer would be, you would essentially, to show you, 4 to what power is 32? You could look at it like that. 4 is really 2 squared to the x for question mark. 32 is, 32 is 2 to the 5th. That you multiply, 2x is 5, so x is 5 over 2. And then 1 over 2 plus 5 over 2 is 6 over 2. 6 over 2 is 3. Boom, your answer is 3. So sure, we could do it that way. But this tells us to write as a single logarithm, so we're going to use that as our focus. We're going to focus in on that. So I'm going to basically reverse the expansion of a product property. And we're going to put it all together again like Humpty Dumpty. So we have the sum, they're both base 4. So this is going to become log base 4 of 2 times 32. And I'm showing the steps, although you could put it all together, in fewer steps, of course. And then that becomes log base 4 of 64. I guess you don't need the parentheses, although some people's handwriting makes it a little hard to tell like where your exponents are, subscripts are. So if you put parentheses around the things that are in line with the word log, maybe that'll help you out. And now this is able to be simplified even further. So this might be done some of the time, right? But in other instances, you have to go a smidge further. So in this particular case, we are going to ask ourselves 4 to what power is 64? And we should know that the answer to that is 3. 4 to the third is 64. I know I probably mentioned it in other videos, but I think it's a really good idea that when it comes to knowing 2 to a power, you want to know basically x, all the integers essentially from, really you should know to like negative 10 until positive 10, all the integers. Really 11's not that hard and so on, but there's no reason you shouldn't know 2 to the 10th power, and therefore up to the negatives. It's just 1 over 2, 1 over 4, 1 over 8, 1 over 16, 1 over 32, 1 over 64. And then you use what? 128, 256, 512, and 1024. And then that's 10th power is 1024 or 1024. So obviously 2048 is 11th power and 4096 is the 12th power. So really you could know up to there. When it comes to 3 to a power, I think you should be able to do up to maybe 3 to the 5th, I guess, right? Because 3 to the 4th is the same as 3 squared, and then that thing squared, so it's 81, times another 3, 243. It's not that bad, right? 4 to a power, I definitely know 4 to the third, and then 4 to the 4th is the same as 2 squared to the 4. So that means it's the same as 2 to the 8, which we already know, so no reason you can't know that. And then 4 to the 5th is going to be the same as 2 squared to the 5th, so 2 to the 10th. So yeah, we could know 4 all the way up to the 5th power. Sorry for my little tangent right now. But if what I'm trying to get at is if you don't know, right, 3 all the way up to the 5th power, 4, no problem up to the 5th power, 5, I guess 4th power, 6, 3rd or 4th power, 7 to the 3rd, 8 to the 3rd. I guess you could know 8 to the 6th. No, 8 to the 3rd. 9 to the 3rd, 10 to whatever, who cares? if you don't know those really well, you're going to find a lot of this content very difficult. So that was I'm off my soapbox. Sorry, done. Let's move on. Sorry for the tangent. All right, next problem here. This one, I spoke about one like this in the last example, that it's very easy to mix a minus sign like that one up with the minus sign like that one. One of them is going to become division. The other one is just going to stay the way it is, and you need to recognize, what to do and when. So I would suggest you stare long and hard at that quotient property to pay attention to where the minus sign is. So like in the property, that's your m and that's your n, if that helps you see. So what does this become? This is log with an invisible base 10. We already spoke about that. Its quotient property, my numerator will be 4x minus 3, and my denominator is x. I would not simplify what you have going on inside of that parenthesis. It's not worth it. It's messier. It's better to leave it altogether as a fraction. I know I had some students saying, should we make it 4 minus 3 over x? No, you shouldn't, okay? Because basically, you're going to want to find out, oh, when is this thing inside equal to 0, or when is this thing inside undefined? And you do that by setting the top and bottom equal to 0. So you want it to be one solid fraction anyway. So you would not try to simplify that in this situation. And that is the end of that. We cannot take it any further. The end. All right, next example here. We have, I don't know if this color is going to show up, log. Too bright? What do you think? Log, I always go to like the browns when I do yellow. Log, olive green maybe, of 25 times 4 is essentially what we're doing, which is log, again, invisible base 10 of 100. And similar to example 5a, this can be taken a little further. Again, we have an invisible 10. This is common log. Natural log is ln. Common log is log with nothing there, meaning it's an invisible base 10. This is asking us the question, 10 to what power is 100? So the answer is 2. Don't get it mixed up with the 10 to a powers. I feel like sometimes people get it a little bit mixed up and they overthink it and they count how many digits there are. Like usually 10 to the second is 100, people are fine. But when they get to like, I don't know, like here, I'll see a lot of people think that this is 10 to the 6th. That's not 10 to the 6th. You count the number of zeros, it's 10 to that power. So if you didn't know that, you're welcome. All right, next one is this purple guy here, and it is just like example 5b. Of course, that's, usually how a book does it. A log, again, this is base 10. They're all pretty basic. No pun intended. 7x plus 6 is my numerator, x is my denominator. Again, that sum on top is not to be confused with anything to do with product property, okay? It's not a log m plus log n. It's not that situation. And that is the end of that set of examples. So hopefully that was helping you condense. When you're done condensing, you will either have it down to a single logarithm, meaning the log function is only written one time at most. And I say at most because it's possible you could evaluate that expression and have no log in your final answer. So if that was helpful to you, I do have another video. Example 6 is more condensing, since that is the one that people mess up the most. And it's usually when you have, I already foreshadowed about this, something minus something else minus something else. Okay, I'm just making these all different things. When you have that double subtraction, the mess that gets made, a bit wild. So look out for that, example 6, the next video. But if this was okay, helpful, you feel a bit better, go ahead, give thumbs up, interact, let me know that it's good, or if I need to do something different, thumbs down if you hate it. Questions, comments, concerns, requests, feedback, put in the comment section so I get an alert. And you can even straight up ask me to do a specific example. If I'm sitting here recording anyway, I will just jump in and do it. Put in your request for your test reviews for your class, for your final exam. I don't care. Go nuts, my darlings. Check the next video, check the description box for some links, and check the playlist, find what you need. And bye for now. Adios.